students, today's agenda is to check homework. We'll be factoring and multiplying rational functions, and you will be able to do 7.7. Today, students will be able to factor and multiply portions of rational equations to modify how they look. We will also, if we cancel, we will continue to work with wholes. So today we are not going to graph, but we will be finding those wholes in the graph if we were to graph the functions. So here it says multiply to create a rational function in the form of p of x over q of x. Simplify first if possible. So in here we see if any of the factors in the numerator and denominator are the same, we would be able to cancel, and that will create a whole. In this case, we don't have anything like that, so we're just going to multiply. And the quick route, you can do FOIL in here first, outside, inside, last, and then combine like terms. But what I like to do is the happy face. The happy face will make a nose. Okay, so that's what I usually say, but in here is going to be backwards. Let me do just to show you the happy face, what I mean. What I do is, okay, x times x is x squared. That's for the first term. And then we also have 5 times 1 is 5. That's for the last term. But for the middle term, I just say, oh, my happy face will create that. And I can just say 5 times x is 5x. X times 1 is x. And together 5x and 1x is 6x. So we're doing FOIL, but the outside and the inside, we do it directly in here within the factors. Now, because we have these ones up there, what I do is x times x is x squared. 3 times 2 is 6. And it's positive because both are positive. But then I just do the inside and the outside together. So x times 2 is 2x, and 3 times x is 3x. And so that's 5x. That's all you have to do for this lesson. Just rewrite it in p of x over q of x. This is number 2. We're going to be doing the same thing, but in here we notice that we have x plus 4 in the denominator and numerator. So in here, one of them will cancel with this one, but we still have 2 more. So it's going to be x plus 4 squared over x plus 3. And so with perfect squares, if you recall from previous lessons, you have to do this. So it's x times x is x squared. 4 times 4 is 16, but for the middle term, all you have to do is multiply x times 4 and double that. X times 4 is 4x, double that is plus 8x. And in here, since we don't have anything else, all you have to do is rewrite it and you're done. The only other thing that we need to do is, because we canceled one of the factors, that means that if we were to graph this function, it would create a whole. And again, we're not graphing today, but let's go ahead and find that whole or removable discontinuity. So x plus 4 equals 0. We subtract 4 from both sides, and x is -4. Then we're going to substitute this in the simplified, and you can use this one or this one, whichever one, to find the value of y. I think it's easier to just use this one, but go ahead and use both and you can check. So replace -4 in there and also there. And so you get -4 plus 4 is 0 squared over -4 plus 3 is -1. 0 squared is 0 over -1. And 0 divided by anything will always be 0. So my whole will be at -4, 0. Once we graph it, that means that will leave an empty point. Okay? For the next one, it says factor to create a graphable form of the function, simplify if possible. And so what we have is two quadratic equations. And so for those, you can just see, is there something that I can multiply and give me positive 4, but when you add them is negative 4. When this is positive, that means that both of these will have this sign, so both will be negative. And what are factors of 4? 1 times 4, but when we add them, that will be negative 5. But 2 times 2 is 4, so negative 2 times negative 2, positive 4. And negative 2 plus negative 2 is negative 4. So yeah, those are the factors. I open my parentheses, x minus 2 times x minus 2. Or I can just put x minus 2 squared because they are exactly the same. We do the same thing for the denominator and we say, this is negative. When we have a negative, that means that one is going to be positive and one is going to be negative. I look at the sign in the middle, and since it's positive, the bigger number is going to be positive and the smaller is going to be negative. Okay, so what two numbers equals negative 12, but when you subtract them, so this not only tells me that one sign is positive and one is negative, but also that I'm going to subtract the two factors. Okay, when we subtract those factors and it gives me 4, what would those be? Well, we immediately think of 1 times 12, 3 times 4, and when we subtract 1 and 12, it gives me 11. Not that one. The other one is 3 times 4. When I subtract them, that gives me 1. But we also have 2 times 6. Well, 2 and 6, if I subtract them, it does give me the 4. Remember, 2 and 6, the bigger one is 6, so that goes with the biggest sign, or the sign of this middle term. So that was kind of a quick review. Again, if they are different, you're going to do two things. One is going to be positive, one is going to be negative, with the biggest one having this sign. And the other thing is that you have to subtract them, not add them like we did in here. This tells me we have to add them. This tells me we have to subtract them. 6 minus 2, 4. Now we write x plus 6 times x minus 2. And so it says simplify if possible. So x minus 2 divided by x minus 2 equals 1. That's why we cancel that. And so let me rewrite it in here. My simplified function will be f of x equals x minus 2 over x plus 6. That, by removing that part, it means that it will create a whole or removable discontinuity. So we just say x minus 2 equals 0. If we're subtracting, the opposite is to add 2, and so x will be 2. Then we're going to substitute that value in the simplified form of this function. And so 2 minus 2 over 2 plus 6, and that's f of x equals 2 minus 2 is 0. 2 plus 6 is 8, and 0 divided by 8 is 0. So in this graph, if we were to graph, we're not graphing again, but if we were to graph, the whole will be at 2, 0. Okay, that means that that point, the graph will go through that point, but will jump over it because that's going to be an empty point. Okay, for number 4, it says the same thing, factor to create a graphable form of the function, simplify if possible. And now I have a quadrinomial and a binomial. Okay, and so to factor here, this is a special square. It's another review. Whenever you have a difference of perfect squares, all you have to do is open two parentheses, take the square root of the first term, so the square root of x squared is x, and put it in each one of those parentheses. Then you're going to do the same thing. You're going to take the square root of the second term without taking into consideration the negative, and so it's going to be 1 because the square root of 1 is 1. But because of this difference, you're going to put plus and minus. Okay, and if you recall, just for the happy face, 1 times x is 1x, x times negative x is negative, x times negative 1 is negative x, and so they cancel, and that's why you don't have a middle term. Okay, so that's just to check. Okay, but these are my two factors. Whenever you have a difference of two perfect squares, you just open parentheses and put the square root of the first one in here, square root of the second one, one positive, one negative, always. For the next one, you can try grouping, but also you can just try what we've been practicing with, which is synthetic division. And so for synthetic division, remember that we get the coefficient and constant and put it in here. So 1, negative 3, positive 3, negative 1. And because the leading coefficient is 1, then we get the factors of the constant only. In this case, it's only negative 1, so we always use the positive and negative of the factors. We don't have a list bigger than that. So let's try first x plus 1. And when we're trying to see if that's a factor, then what we will do is change to the opposite. So since it's plus 1, we're going to use minus 1, the opposite. Okay, bring the first number down and we start multiplying. Negative 1 times positive 1, negative 1. Combine this, and so negative 3 and negative 1 is negative 4. And repeat the process. We multiply. Negative 1 times negative 4 is positive 4. We combine 3 plus 4, and that's 7. And negative 1 times positive 7 is negative 7. We combine, and we get negative 8. Since this last term is not a 0, if this was 0, that means that, yes, this is a factor, and this will be the other factor. But because it's not 0, that means that it has a remainder. What do we do? Now we'll copy this again and try the next one, which is x minus 1, to see if that's a factor. Okay, so we put the 1, the negative 3, positive 3, and negative 1. This is negative 1, so we're going to use positive 1 in here. Again, we bring down the first number, which is 1, and start multiplying. 1 times 1 is 1. Combine, and we get negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. Combine, and 3 minus 2 is 1. 1 times 1 is 1. Combine, negative 1 and positive 1 is 0. So yes, the remainder is 0. That means that this is a factor. And we write x minus 1 times, this is the coefficient to the next, in descending order, the next variable. So x to the second power. And the reason is because we took one of those, x to the third, one of those is here. So we have 1 x to the second power minus 2x plus 1. And in here we can see that this is a perfect square, perfect square. If we take the square root of 1, that will be either positive 1 times positive 1 or negative 1 times negative 1. And half of negative 2 is negative 1. So yeah, it's a perfect square. For perfect squares, all you have to do is open your parentheses. Square root of the first one is x. Square root of the last term is 1. And we get the sign of the middle. Bring this x minus 1 down. And if you can't see that, you can also say, okay, because it's positive, we need a number. We need two factors that multiply equals positive 1. Well, it's only 1 times 1. But the sign of the middle, both, when it's positive, both have this sign. Okay? Negative 1 times negative 1 is positive 1. Negative 1 and negative 1, negative 2. And that's it. Okay, so now we're going to bring this up there in the numerator. So that was x minus 1 times x minus 1 squared, but guess what? It's actually x minus 1 cubed, and I will rewrite it, but you know what? I noticed that we can cancel this. One of the x minus 1 cancels with the x minus 1 in the denominator, and so the simplified form is with factors, of course, x minus 1 squared over x plus 1. The only other thing that we need to do, so this is what we're looking for, but the other thing that we need to do is to find that removable discontinuity, or that hole in the graph. So the hole created by the discontinuity is x minus 1, whatever we cancel, equal it to 0, cancel by adding 1, x is equals to 0 plus 1 is 1. And then we will replace that in our function, in the simplified function. So 1 minus 1 squared over 1 plus 1. 1 minus 1 is 0 squared over 2. 1 plus 1 is 2. And 0 squared is 0 over 2. And 0 divided by 2 is 0. So my removable discontinuity will be at point 1, 0. Okay, that was fun. We reviewed a lot of factoring concepts and processes, so interesting. And with this, we end our lesson. If you can please give us a thumbs up, subscribe around here. This is the link to the entire unit, and here you will find the next lesson.
Have fun! Have fun!
Now you're able to do 7.7 and have fun.
Have fun! Have fun! Have fun! Have fun! And have fun learning math!